Hi, welcome to our math. Today I'm doing a series of videos on inequalities. And in this video, we are graphing a system of inequalities. System means two or more equations or inequalities. So we're going to graph two inequalities. For y is less than 3/7 x, we're going to imagine a plus 0. So our y-intercept is 0. This is where we're crossing the y-axis. And then my slope is 3/7, which means I go up 3. My slope is 3/7, which means I have a positive 3, rise of 3 over positive 7. So I go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Now I like to have 3 points, so I can't do 3/7 again and stay on the field that I gave myself. But I can do -3 over -7 because a negative divided by a negative is positive. So from here I can go -3, -7, 4, 5, 6, 7. And now I can use my ruler to verify that indeed these 3 points line up nicely. Now, there's no equal sign, which means we don't actually equal this line. So we're going to use a dashed line. The dashed line means we don't equal. Now, this line is like a fence. An inequality is like a fence, and now we have to figure out which side of the fence our yard is on. Is our yard on the top, or is our yard on the bottom? Now, some of you might know that because it's y is less than, y is up and down, less than means going down from here, which means we would shade below. And that's one way to do it. The other way is to test a point. And so I usually like to test something like 0, 6. If I test the point 0, 6, what I'm doing is I'm saying if y is 6, and x is 0, do I have a valid point? Because the idea is every point in the shaded region should satisfy the inequality. So does 0, 6 satisfy? And you're thinking, why did you go on a place where you knew it wouldn't? Because this doesn't satisfy. And the answer is because I always tend to do positive numbers, and I like the positive y-axis for my values. I think it's the easiest to substitute in. I knew it was going to be false. That's okay. Now, if I was just graphing one line, I would shade this whole area in, but I'm not graphing one line. I am graphing two. The second line is x is greater than -7. This is a vertical line. One variable means horizontal or vertical. X has the vertical. So 1, 2, 3, 4, 5, 6, 7. And again, it doesn't equal. So again, I need to do a dashed line. I still always use my arrows. X is greater than, which means I'm shading to the getting bigger side. Okay, the last thing I'm going to do is 2 items. Number 1 is I'm going to note this point. This point right here is -7, -3, my point of intersection. And the next thing I'm going to do is where we shade both of them is over here. So all of these points satisfy both equations. So this shaded region bordered by these dashed lines with the intersection point -7, -3 is the solution to the system. All right, the next one is a little simpler. The first one, x is less than 3. Again, there's no equal sign, so we come to x is 3 and we put a dashed line. And because x is less than, we know we're shading on this side of the line. Next we have y is greater than or equal to -5. So 1, 2, 3, 4, 5. Greater than or equal means it's a solid line. It means we can equal the line. So equal means solid. And then greater means above. So to finish this off, this intersection point, the reason I said it's easier, the intersection point is 3, -5. It's given to us. The only thing we had to do is figure out that we shade in this quadrant. All right, I hope you've enjoyed the video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.